Good everyone. I hope you guys have an amazing day. So, what I'm going to do today, I will be starting a tiny, very tiny series on Einstein Copilot. Um, as you know, the right, Salesforce has been talking about Copilot almost an year now, right? Even their Dreamforce has talked about artificial intelligence. Um, and also, Microsoft launched their Copilot, right, in Teams. If you have used Teams, you might have seen Copilot. That being said, right, I before I jump into Salesforce Copilot functionality, prompt engineering, I would like to talk about some basic fundamentals which you should know, right? Because it will help you understand some of the terminologies that's been spoken quite often these days. For instance, generative AI, right? Which is very commonly it 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 is very common today, right? Everyone talks about it. So if I wanted to put it that way, so today all I'm going to do, I'm going to talk about generative AI, and let me maximize the slide, right? So that's all this session is all about, because I believe, if I cover some of the basic fundamentals around generative AI, it will make your journey in the world of AI much easier. Now, I wouldn't be talking much from a Salesforce perspective. I will be talking from a generic perspective, and because those who don't know me, I don't just do Salesforce. I also run Climate Change Foundation, and one of the core thing what we do is to build large language model on climate change, which means we are heavily involved in the space of artificial intelligence, which also mean we do a lot to do with generative AI, and everything we build is from the ground up, right? We are not using any open AI tech. We are everything. So last year I did a lot of work. I started building everything from the ground up, right? I trained, well, because we have to train our model with large number of data. Uh, so I will get into that. So to keep the story short, right? I have a lot of experience in artificial intelligence space, right? That was one of my theses when I went to MIT. There was a neural network. I written a compiler at MIT in neural networks. So I've been in this space for past 18 years, so I know what I'm talking about. So I'll try to make this very simple, so that excuse me, so it makes it very easier. Now, what is a generative AI, right? If you ask anybody what is a generative AI, the first thing that comes into mind, ChatGPT, which is great. I credit Sam Altman. He is instrumental in taking a complicated piece of a technology and made it simple, so that even a barber or even a butcher guy talks about generative AI. How cool is that, right? That's the power of ChatGPT. And the ChatGPT, behind the scene ChatGPT, right? Whatever you see, right? You give a command, you you try to type in a simple English, it give you response in a simple English, right? It's like you're having a conversation with a mate. So that the technology that goes under the hood, that is what generative AI, right? So if you want a more um, uh, official definition, right? It is a subset of artificial intelligence, right? That is designed to generate new content. So you can ask ChatGPT, "Hey, create me this content which never existed before." It will do that for you. Create an image. I wanted to create an image, let's say, with a Picasso or painting um, something, right? It will try to do something like it will generate it for you. Um, and it will try to create a poetry for you. If you, let's say, if you gave ChatGPT something, say, generate a poetry for me based on XYZ topic, it will generate that content for you, right? Um, Traditional AI, right? So now I mentioned that traditional AI, like for instance, you might have, there's a very common concept, supervised AI and unsupervised, right? Which is most commonly what I've heard. But the thing with them, right? you know, the traditional AI models, let's say your classification models, which predicts if you got a cancer, it's still not got a cancer, right? Based on the data set it gets trained on, it's still a very valid models, right? It still get used in a lot of places. Um, but the thing is, those models will not generate a new data for you. Like if you tell them, hey, generate a poetry for me, it won't be able to do that, right? Um, Whereas the generative AI will create a new data based on a pattern and structure it learned from a training data. Now, obviously, in artificial intelligence, everything is data, right? You got to train your model, and based on the training, your model will try to predict, try to learn, try to generate a new data. That's all in a simple nutshell, generative AI. If you wanted to generate, so how do you explain this to a layman, right? If you ask me what a generative AI is, you can say, I'm dealing with an artificial intelligence which can generate a content for me, right? If I tell an AI, hey, generate a music for me, or generate a poetry for me, or generate an image for me, it will do that for you, right? Because obviously, if you take an example of OpenAI, they've trained their model with a huge data set. Pretty much everything they found on the web, they trained it. So that's in a nutshell what a generative AI is about, right? Now, what are the key characteristics? As we already talked about it, but just wanted to touch base that again so that it's become very clear. Creation of new content, as I mentioned, you can create a new content. For instance, if you wanted to create a poetry, if you wanted to create a new image, if you wanted to create a new article, you can do that using ChatGPT, or for that matter, any model that's built using generative AI. It often learns from a large data set. That's why I said that, right? It revolves around large language data model, right? Now I'll get into LLM, or in short, right, for the large language model, um, but I'll get into that. So any models, right, in generative AI which get trained using large data set is often referred to as large language models. So most of the generative AI, anything to do with the generative AI, right, is often associated with a large data set. Otherwise, it's ineffective. How are you expecting a model to generate a new content for you if you're not training it, that model using a large data set? Then failure to do so will lead to other complication, which we're gonna look at it at the end. The drawbacks of generative AI. It uses advanced architecture. One is a transformer, variational autoencoders, and there's something called GANs, right? Generative adversarial networks. So in today's episode, I will tell you what transformers are, which is very common for GPTs. You might have heard about GPTs, right? I'll discuss that as well. So that's the next thing I'm going to talk about, the type of models, right? Obviously, when you talk about generative AI, there are different models. Like I said, think about model like a box, right? Where you pass the data, and that model and the box gather the data, learns from it, and it gives you the expected output, right? Think about a black box where you're feeding the information, and on the other end the data is coming out, right? And the more information you feed to the box, the more smarter the box gets. So next time when you ask a question, the box will know, oh, okay, I know this content, so I can pretty much generate something else for me, right? It's like human beings, right? I mean, obviously, it's a bit unfair to compare a model with a human being because our brain is way too complicated and way too capable of a lot of things, right? So, but just take an example, right? When it comes to human being, we are capable of um, learning new things and innovate based on things we learn, right? And even generate new content based on something which we learned. So something on that line, right? We can say. Okay, now let's look at generative AI models. So there are different kinds of models. So, but what I've done, right? The most commonly used and most commonly spoken about models in the world at this stage. So I've talked. I've selected three models. GPT, you might have heard about it. If you're a ChatGPT fan, so you would have seen that ChatGPT has an option where you have a GPT store where you can create your own GPT models, right? Obviously in a paid version, not in a free version. So GPT stands for Generative Pre-trained Transformer. Now I will tell you what transformer in a minute after this slide, in the next slide, and uh, I'll tell you how Google played an important role uh, in this transformer architecture. So GPT is very commonly used. Your chat GPT is based on that. Now GPT use cases are text generation. You can summarize it. So now if you know what I mean by summarization, you can give your entire passage to ChatGPT and you can say, hey, can you summarize it in 50 words? It will do that for you. It can translate it. It can also do question answer kind of stuff, right? Then you have DAL E. So it is usually for image. So you might have, if you've used ChatGPT, you might have seen they have DAL E. So this is a model by OpenAI, and it's a very popular one. So if you wanted to do art and design, content creation, usually to do with the image generation, right? So they use this. And then we have something called very powerful, which is BERT. BERT depends how you pronounce it, right? People from different parts of the world pronounce this acronym in a very different way. Some of the pronunciations are a bit weird, but I'll keep it as BERT. Once I was talking to somebody, um, I don't want to name a place. It sounded to me as talking about a bird, right? I was like, why talking about bird? It's a bird, right? I mean, some accents, right? But anyways, never mind. Sorry, I digress. So it is bidirectional encoder representation from transformers. Like I said, these are transformer-based models. Their underlying architecture is based on transformer. Now, excuse me. There are a lot of use cases like natural language understanding, sentiment analysis, named entry recognition, and question answer. Now, what is natural language, right? You might wonder. So it is also it's a so natural language. Think about it. Like let's take an example of ChatGPT again. You are asking ChatGPT, "Hey, can you tell me what's the weather in Wellington today?" Right? So it will go and search whatever it wants to do and give a reply back, right? So you're having that human-like conversation rather than saying, "If X equals to Wellington, then show something," right? Rather than writing a programming kind of language, it's using human level conversation and giving you result back in the way you understand, right? That means in a similar tone, a human language. So the expression of the language is human in natural language processing. That's why the term natural language is used, right? Otherwise, they could have used C sharp language or Python language, right? But it's natural language. It's a language which you can understand, right? You could use Hebrew, it will give you in Hebrew, or if you wanted to talk about um, Norwegian, it might, if you are a Norwegian speaker, you can start Norwegian. And if you're Italian, it's a buongiorno, come ti chiama, so it will give you response in Italian, right? Or Spanish, hola, ¿cómo estás, señorita? So we'll kind of, my Spanish sucks, so let's not even go there. Um, Now, I am a big fan of natural NLP. So now there are different toolkits out there for NLP, right? So if you're a Python developers, there are a lot of libraries out there which can help you do NLP kind of things, right? So I'm not going to get into that. So just to give you a very basic understanding. Okay, now, what are transformers, right? Now, it's a type of a deep learning model architecture, right? Obviously, there are machine learning, there's a deep learning, and deep learning usually deals with neural networks, right? So, neural networks, think about like a brain neurons, and you're replicating a similar behavior in a computer, right? Using artificial neurons. And now there are different algorithms there, and I don't want to get into that. But just remember, it's one of the type of deep learning that significantly advanced the field of natural language processing and machine learning. So there was a paper presented by uh, this guy um Vaswani in 2017 by Google team. Attention is all you need. So it's like, you have a word. Um, so they split the word. So you have a sentence statement. Sorry. Um, like for instance, Mr. Cohen decides to eat falafel tonight. I mean, I like falafel, so just it's not that I'm eating that tonight, but just so in that, what happens is, right, the transformer architecture or attention is all you need. They when they traverse through the word, they extract each word, use as a token, and pay special attention to it. Um, I I don't know how to simplify it. So they basically use a parallel architecture, parallel computing architecture, where every token in the process parallelly, and it makes sense out of it, right? So I mean, perhaps I can explain transformer architecture in the future, maybe in advance um, conversation. But for now, just think about that, right? All of your GPTs, BERT, Dale, right? They rely on transformer architecture, and transformer architecture is a deep learning architecture which relies heavily on neural networks, right? And the whole point is, whatever conversation you're having, right? Big statement, it will decipher it in such a way that it makes sense out of it, right? So that's irrespective of the languages used. So your GPT, BERT, and all other models, Gen AI models, uses this architecture. And pretty smart guys from Google, they came up with this architecture. And which forms the foundation of what you see in ChatGPT, or for that matter, any other Gen AI um, application that you see in the world as of 2024. Okay, this is my favorite topic because I built LLM, so I know this is my favorite part. So it's a large language model, right? So it's an AI model, right? Decides to understand the human-like text. So obviously, like for instance, let me take an example of the climate change. We have to train our model on a huge, substantial, gigantic amount of climate data available in the world, right? So it will give you predictions. It will give you human-like uh, text. It will give you um, all the indices, all the required information needs to make a decision, right? So um, it will take care of the grammar. It takes care of. It's like you're talking to a friend who is PhD in climate change, if I put it in simple way, right? So I have a model sitting there. I can ask the model any question around the climate change. For instance, carbon sequestration, which um, carbon sequestration is one of my favorite project. That's something I'm looking to it. So how do we gene edit certain plants to absorb more carbon dioxide? Can we gene edit every plant to absorb more carbon dioxide? No, really. We need to worry about the plants which are, say, have deep roots, which are bigger in size, and also we need to consider the possibilities, right? Some of the gene editing what we do should not affect humans, because obviously if you're going to gene edit a corn crop, the last thing you want, the person ends up dying eating the corn, right? That's all things we need to consider. So we built a large language model which is helping us build that kind of things, right? So just in a simple terms, think about the black box analogy I gave you, right? So black box, you pass the data, the box gets smarter as it get trained, and then your box is your friend. You're gonna sit and talk to the box. Now that sounds like a bit weird analogy. It's so, but You know what I'm trying to say. So it is relying on natural language processing. NLP is very important when you're talking about Gen AI, when you're talking about large language model. You cannot miss natural language processing, right? Otherwise, you cannot really build your large language model, and you need to train your model with a large data set. It's very important. If you don't do that, your model won't be effective. Then there is a lot of issues associated with the model, which I'm going to talk about in the next slide, right? Okay, now we got few concerns for generative AI. Hallucinations, data privacy. Now, hallucinations means you are training a data, so you expect an output from a model, right? And instant model created something for you which is absolutely ridiculous, right? Make no total sense. Um, let's say, I don't know which funny example I'll give you. Uh, okay, let's say you train a model on climate change, since we're talking about climate change, and I asked my model, for instance, hey, can you tell me if carbon sequestration will solve the problem for climate change? And instant model will come up and say, hey, yes, it will solve the problem, but it will also kill human beings. So, do you want to proceed? No, do not want to proceed. And what about the ethical consideration, right? Then the model will say, you don't have to worry about it as long as the climate is protected. No, that's not great either. So, and then sometimes they started giving faulty information, right? To say, hey, we don't have to worry about, say, big plants. If even if it's a small plant, it has a capability to absorb carbon dioxide, because obviously the plant is responsible for photosynthesis, right? Now, there's a gene involved in a plant which does that. Now, you can modify that to absorb more carbon dioxide, but not every plant is capable of holding extensive amount of carbon dioxide. So we need to factor that, right? If the model started to hallucinate, start giving false information, that means my model is not effective, right? Then the data privacy, right? Sometimes what happens, you might train your model with a lot of people information, personal information. So you got to be very careful with that, right? Sometimes people start spilling out people information, like which you shouldn't be, which is going to cause a compliance and might even trigger a lawsuit in certain jurisdiction, depending where you are in the world, right? And then it might even plagiarize the content, right? Sometimes your generative AI model will generate an image so close to a real person art and say, hey, look, it's my content. No, it's not. It is someone else's content, which AI tried to plagiarize it. So you got to worry about that as well, right? These things are very important. And then ethical use and misuse, like I said. And if the generative AI will say, hey, let's do the carbon sequestration, let's don't worry about the implications on the human life. Who cares if few people die, right? So that is a serious ethical issue. And also you might have heard about deepfakes, right? People are using deepfake technology to do crazy things, which is really unethical and absolutely ridiculous, right? And so that's immoral and illegal and unethical use of generative AI. So this, in nutshell, what generative AI is all about, right? Now, I hope that you guys learned enough. I understand that I haven't covered too detail, right? I don't think you guys need to know if you're going to work on a Salesforce ecosystem, right? Um, I got really passionate, so I covered a little bit extra stuff so that maybe, if you're interested, you can go and read uh, on site a different material. There are different literature out there. You can read research paper, white paper on generative AI. Dell has done a pretty good work. NVIDIA, that's one of the company. They do a lot of work on deep learning, so you can research there. You can read some of the white papers there. ChatGPT has few. Um, I think even or Apple has, Microsoft has as well. So it depends where you wanted to. There are a lot of content out there. So pick and choose which way you like and which way you feel comfortable, right? And start learning about it if that's what your interests. But that being said, right, I wanted to make sure you guys have some basic understanding before we get into Einstein Copilot. Next time, I'm going to explain to you about prompt engineering because a lot of things are based on prompt engineering. And I honestly do not consider prompt engineering as artificial intelligence. I mean, no offense, but it, yes, it calls an underlying AI algorithms, which is true, or I mean, if which is great. But if you don't understand, let's say, some of the algorithms work, if you don't understand, let's say, what is a supervised model, right? What is support vector machine? What is a random forest or RNN, right? Recursive neural network or backpropagation algorithm. If you have no idea about any of this stuff, right? If you think what I'm talking is Greek and Latin, and if you call yourself an AI engineering, then I find it a bit challenging to accept that, right? Because that's not artificial intelligence. That is you're using a tool to achieve an outcome, which is fine if that's what you're after. There's nothing wrong with that. But I will not consider you as an artificial intelligent AI engineer. So yeah, that's one of the things I often tell people to be wary of, especially if you're a programmer. It's okay to do prompt engineering, but please make sure you understand at least some basic understanding, right? There are different books out there. Grab a book on machine learning. Try to understand what is supervised learning, what is unsupervised learning, what is k-mean, what is the k-nearest algorithms, right? What is the decision tree, support vector machine, random forest, yeah, classification, linear regression, and logistic regression. At least have some basic understanding of it, right? This will set you for good. And so yep, so that's all I wanted to cover in this episode. Hope you guys have an amazing Monday. Adios.